Okay, so what we will do for this is, so we cannot change x power m because we already prefer to have x power m in the term. So we will put x power m, and then it will be a power m plus 1. Okay, and then m plus 1. And then what I will do is I can change this m is equal to 1 and then infinity. But by doing this, what I am doing is, actually I am skipping the first term. I am skipping it. Okay, so because I'm skipping the first term, so then I can write it outside of this sigma notation. So what will be the first term? First term will be with m is equal to 0. So it will be 0 plus 1, 1 into a 0 plus 1, that will be a1, and then x power 0. So this will be the first term outside will be only a1. So now we have all set with this, so that is equal to 0. So now for this equation to hold true, a1 should be equal to 0, and the second term, now we can take x power m as common, and then as one more step, so I can write like m is equal to 1 to infinity, m plus 1, a m plus 1, and then plus 2a m minus 1, all are common, and then x power m is equal to 0. So this, for this equation to hold true, a1 should be equal to 0. Okay, so a1 should be equal to 0, and then this term in the bracket should be also equal to 0. So m plus 1, a m plus 1, and plus 2 am minus 1 equal to 0. Okay, so in this way, what I can do is, I can write am plus 1 in terms of this minus 2 am minus 1, and then it will be m plus 1 divided by m plus 1. So like I did before, we can set up a table for m and am plus 1 terms. So in this case, we will start from actually 1. Okay, because if I take 0, then it will be 0 minus 1, a minus 1. So we are not considering any a1 0 1 a minus 1 term. We will be starting from a is equal to 1. So a is equal a0. Okay, that's why I will start from m is equal to 1. Okay, m is equal to 1, and then for this, for m is equal to 1, and then I will continue it with m is equal to 2, with 3, and then 5 6 terms we can take, 4 5 6 7. Okay, so in this way, what I will get is, for m is equal to 1, I will get a2 is equal to, and then for here I will get a3 is equal to, with the application of this m values, a4 is equal to, a5 is equal to, a6 is equal to, a7 is equal to, a8 is equal to. Okay, and now what I will get over here with am is equal to 1, I will get a naught. Okay, so it will be minus 2a naught over 1. Okay, over 1. Okay, and then what I will get, a3 I will get is equal to minus 2 a1. Okay, and then I will get minus 2. Let's complete it like this: minus 2 minus 2 minus 2 minus 2. and then here I will get A1, here I will get A2, A3, A4, A5. We can complete like this table, it is much easier. Okay, and then divided by m plus 1. So if it is 1, so it was, so for example, if m was 1, m plus 1 is A2 over 2. So it should be 2 actually here. Yes, 2, I made a mistake. And then here it should be 3, here it should be 4, here it should be 5, 6, 7, and then 8. Okay, so now I can represent all of these values in terms of A0. So for example, A2 has been represented with A0, and we have already said that A1 is equal to 0. Yeah, A1 is equal to 0. So since A1 is equal to 0, this term will be 0. So A3 is equal to 0. So this term is in terms of A3. So this term will be equal to 0. Since A3 is equal to 0, so A5 will be 0. So A5 is 0, then this term will be equal to 0. So every alternate term will be equal to 0. Okay. So what I can do for these terms? So this is minus A0. Okay, this is minus A0, 2 over 2. And how about this? So this is A4 is equal to minus 2 over 4 A2. Okay, so what is this? So A2 minus 2 A2, and then that A2 is equal to minus A0. So it is plus 2 A0 over 4, right? Plus 2 A0 over 4. And then what it will be? So it is minus 2 by 6. So minus 2 by 6, and then A4 is 2 by 4 A0. So it's 2 by 4 A0. So it will be minus. And then what it will, this term will be, so minus 2 by 8 A6 was this. Okay, so minus it is minus 2 into 2 A0 over A4. Okay, so in this way we can represent it. So what we can do is we can simplify these terms. So this term will be A0 divided by 2, and what will be this term? So this term will simplify into that 2, 2, and then 4. This will cancel out, so this will be minus A0 over 6, and this term will be also cancelled, 2, 2, 2, and then 8, that will cancel. So that will be equal to 2 into 2 into 2, that 8 will cancel with this, and then there will be 2. So this will be A0 over, I think there is some mistake over here, minus 2 A0 A6. So this is minus 2 over 8, and then that was A6. A6 was here, minus A0 over 6. Yes, so A0 over 6, so, or which was same. And then actually 6 was also here. I forgot to put this 6 from here. So 2, 2, 2 cancel, and then this is 6 dot by 2. So it is, and then minus minus plus, so it will be plus A0 over 24. So we can already see the pattern over here. Okay, so let's write down the Taylor the power series. So y of x is equal to now A0 plus A1 x plus A2 x square plus A3 x cube plus A4 x4 plus A5 x5 plus A6 x6, and then so on. Okay, so this will be the first term will be minus A0. So the first term A0 is of course A0, so we will, because that is the arbitrary term. The second term was 0. The third term is now A2. A2 is minus A0, and then it is x square, minus A0 x square. and then this term is 0, and then the next term is a4. A4 is a naught over 2 plus a naught over 2x4, and then the next term is 0, and then this term is minus a naught over 6x6. okay, and then the next term will be 0, and then the that term will be with x power 8, and this will be a naught over 24, and this will be plus. So what we will get is, we can take a naught as common, so 1 minus x square plus x power 4, and then this 2 I can write 2 factorial, okay, and then minus x power 6 over, and then 6 I can write as 3 factorial, so we can already see the pattern, and then plus x power 8, and then 24 I can write as 4 factorial, and then so on. Okay, so now I can see that this is the series for e power minus x square. So for example, we know that e power x is equal to 1 plus x square over 2 factorial plus x cube over 3 factorial plus x power 4 over 4 factorial, and then if I replace x by minus x square over here, so 1, and then x will be replaced by minus x square, so it will be minus x square, and then x square will be replaced by minus x square, so it will be plus x power 4 over 2 factorial, and then therefore it will be, this was the cubic power, it will be x power 6 over 3 factorial, and then it will be x power 8 over 4 factorial. So, and so in fact what is in this bracket is y of x is in bracket is a naught into e power minus x square, so which is the same solution as we got by the separation of variable methods. Okay, so in this way we have done two examples. So earlier, if you see that the solution was this, yes, solution of this equation was, yeah, c with the arbitrary constant c. Here we have taken the arbitrary constant as a naught, so it's the same solution. So again, we have verified by the power series method the solution of an ordinary differential equation. So next we can do the same for those equations for which we cannot directly find the solution, or for which there is no solution available in the normal or elementary function terms. So in those cases we can find the solution in terms of the power series. Here you can see that we have used this tabular approach for determining these coefficients in terms of a naught. I think this type of approach is very convenient to use. In the book there is another method which has been represented over here, but that method is a little bit complicated, that when we compare the coefficients on both sides of the equation. So I think I will prefer to use this type of method for comparing the coefficients. So we will do some more examples for the power series solution of the differential equations in the next videos.